In this session, we will have introduction and basic construction of three-phase induction motor. Three-phase induction motor, also known as asynchronous motor, is an AC motor which converts electrical energy into mechanical energy. It is commonly used motor because of simple and robot construction, low cost and maintenance, better speed regulation, high efficiency and higher starting torque. We'll see the introduction of a three-phase induction motor. The main features of a three-phase induction motors are: the construction is simple and rugged, the cost is low, at the same time maintenance is also very low, it has got high reliability, that is the downtime is less, and at the same time it has got high efficiency, it has good speed regulation and the high starting torque. And three-phase induction motor is working on principle of induction. It has got the self-starting, therefore it needs no extra starting motor. It has a reasonable overload capacity, it is sustaining the overload. That is why the induction motor is a three-phase AC motor and is the most widely used machine. It is whatever you are getting, the most of the application, more than 90% of the applications for a drives, they are using a three-phase induction motor. Then we will look into the cross-section view of a three-phase induction motor. Basically it is consists of a stator and the rotor. The induction motor has basically the two parts. One is called as a stator, that is a stationary part, and the rotating part is the rotor. The stationary part of the stator is basically consisting of a steel frame that supports the three-phase winding. That is steel frame that supports hollow. It is a cylindrical core constructed from stacked laminations. Means once again in the induction motor also the stator and the rotor, they are made up of laminations to reduce the iron losses, that is hysteresis and eddy current loss. Having a number of evenly spaced slots providing the space for the stator winding. That is, we have got the slots in the stator laminations. These are stacked together, looks like a solid body, and in the slots they are placing the conductors. These conductors are wound for three-phase winding. The stator is nothing but a three-phase winding, similar to the alternator. Then the rotor, it is composed of once again the punched laminations. Once again it is also made up of laminations to minimize the hysteresis and eddy current loss, stacked to create a series of rotor slots. In the case of the rotor also you have got slots providing the space for the rotor winding. Here also we have got the two winding. One is the stator winding, that is a three-phase winding. The another one is the rotor winding. Once again in the case of a three-phase induction motor, there are two different types of the rotor construction. One is called as wound rotor. If the motor have got a wound rotor, and it is called as three-phase wound induction motor. And the another one is called as, if it has got a squirrel gauge, it is called as squirrel gauge induction motor. The wound rotor is also called as the slip ring induction motor and squirrel gauge motor. These are the two types of the induction motor, based on its rotor construction. That is, one construction is wound rotor, the another one is called as squirrel gauge construction. I told you that is a rotor and the stator, they are made up of a lamination to minimize the eddy current and hysteresis loss. You can see here, this is a rotor slot laminations. Then here there are slots are embedded here. Here we are placing the rotor conductors. This stamping of a stator, once again it has got its inner periphery, it has got a slots in which armature conductors are placed here. These conductors are connected in three-phase mode. That is, a three-phase winding is placed in the stator slots, and it has got a rotor slots which is on the outer periphery of the rotor. In that also you are placing a rotor conductors. These also one for a three-phase. So another the thing, see the same, it is once again the stator, this is the rotor stampings. If I ask you to draw the construction, then you have to draw this figure and you have to name the rotor, stator core, then there is an air gap between the stator and rotor, all those things you have to write it. Then we will look into the details of the stator. Once again I told you the stator is the stationary part. It is made up of laminations. It is holding the conductors. These conductors are wound for three-phase. The stator is the stationary part. The stator is made up of number of stampings. I told you it is made up of stampings of high grade alloy steel to reduce eddy current losses with slots to carry three-phase winding. These slots are made to accommodate the conductors. These conductors are connected for three-phase winding. These laminations are supported in the stator frame. This is what we are calling as the stator frame. This lamination is supported by this outer frame. It is made up of cast iron and fabricated steel plate. The insulated stator conductors are placed in these slots. In these slots, the conductors are placed. You are seen here. These are the conductors, they are placed and wound for three-phase winding. The stator conductors are connected to form the three-phase winding. Once the conductors are placed here, it is wound for three-phase winding because it is three-phase induction motor. It is wound for definite number of poles. This winding is wound in such a way that it is wound for a definite number of the poles. This is about the stator. It is a very simple. It is a stationary part. It is made up of laminations, and it's in these slots you are placing the conductors. These conductors are wound for a three-phase winding. The windings, that is the three windings, that is R, Y and B windings, they are geometrically spaced 120 degree apart. You can see it is made up of laminations. The stator is made up of laminations. These all stacked together. They are stacked together, forming this looks like a solid body. We have got a slots here. Then the three-phase winding is wound on for these conductors. That is RYB winding is wound on this stator. This is the stator of a larger induction motor. You can see these are the conductors, and these conductors are at the end, they are short circuited. I will explain the concept in the principle of operation. Then the next part of the induction motor is the rotor. The rotor is also built up of thin lamination. It is also made up of a lamination to reduce the losses. The same material as that of the stator. And the laminated cylindrical core is mounted directly on the shaft or a spider carried by the shaft. That is, it is placed on the shaft. These are the laminations, and its outer periphery you have got a slots. These are placed on the shaft. These laminations are slotted on their outer periphery to receive the rotor conductor. Here also you are placing the conductors here. Then based on the construction, I told you there are two types of the construction. One is called as a squirrel gauge. The another one is wound rotor. Now what are the salient features of the squirrel cage and the wound rotor. That is, in the case of the squirrel cage, the conductor's bar led into the slots and short circuited at both ends by shorting ring. The meaning of this is, here the conductors, not a small conductors, it is a conductor bars. They are forced into the slots here, and on either end these conductors are short circuited by a end ring, These are the conductors are embedded here, and those conductors are short circuited by end ring. That is what we are calling as the squirrel cage. Then another one is the wound rotor. The wound rotor construction is similar to the stator. That is, here also you have got a three-phase winding, and those windings are brought outside through a slip rings. You can see here 1, 2, 3 slip rings. It is one for three-phase star connected winding in the rotor also, and these windings are brought outside through a slip rings, and externally it is short circuited through resistance. Ultimately, the rotor construction is, it is a consist of the rotor conductors. They are short circuited. That you have to remember. That is, one is in the case of squirrel cage induction motor, in the rotor itself they are short circuited, whereas in the case of the slip ring induction motor, the winding, the terminals are brought outside through slip rings and short circuited externally. These are the squirrel cage, and it is called as wound rotor. We'll see the squirrel cage induction motor. I told you, here you can see here, these are the slots. In the slots the conductors are embedded. They are forced into the slots. These are the conductors. At the same time, at the end, these conductors are short circuited. These conductors are short circuited outside. If you look into this figure, you will come to know these are nothing but, these are the conductors are in the rotor slots, and at the end these are short circuited by end connection. Okay, this is called as squirrel cage induction motor. Squirrel cage rotor consists of copper bars. It is a conductor is nothing but copper bars, slightly longer than the rotor, so that you have to short circuit, which are pushed into the slots. The conductors are pushed into the slots, the ends welded to a copper end rings, so that all bars are short circuited. In the rotor circuit, there are conductors are embedded in the slots. At the end, these are short circuited. This is a total assembled. You can see here, these are the conductors. That is what we are seeing. At the end, these conductors are short circuited. Then why it is called as a squirrel gauge? It is looks like a gauge. Looks like a gauge. That is why it is called as squirrel gauge. Okay, you can see here. These are the conductors. These are the conductors. These are not parallel to the shaft. They are little bit skewed, so that there should not be any locking. That we are studying in detail. That is, you have to remember that in the rotor, if you have got a rotor conductors, they are little bit skewed, means they are not parallel to the shaft, and at the end these are short circuited. It is through the end rings. Then it is called the squirrel gauge. I'll tell you now. It is a looks like a gauge of a squirrel, therefore it is called as squirrel gauge induction motor. This is a total assembled squirrel gauge induction motor. You can see here, these are the conductors. What we are seeing here is, that is, it is actually embedded. These are the white strips what we are getting. It is a bars inside, and at the end these are the end rings. That is the aluminum ring. They are short circuiting the conductors on either side. Then there are the fans is also attached to the rotor body for the cooling purposes. It is a shaft, and it is a laminated core. What we are seeing here is this yellow part is, that is brown part is, that is the laminated core. Then you can see these are the aluminum bars as a conductors. It is the total assembled squirrel gauge induction motor. See, you can see these are the end rings. This is one end ring, this is another end ring. You have seen here, these are the conductors are placed here. Then we have got a wound rotor, or also called as slip ring induction motor. A wound rotor has a three-phase winding similar to that of stator winding. The rotor winding terminals are connected to three slip rings. That is why it is called as a slip ring induction motor. The rotor windings, there is a basically the rotor is consist of three-phase winding same as the stator, and the terminals are brought outside through a slip ring. That is why it is called as slip ring induction motor. The slip ring brushes allow the external resistance to be connected in series with the winding. The external resistors are mainly used during the startup under normal running condition. The winding short circuit externally. That is basically once again these rotor conductors are short circuited. These windings, the conductors are brought outside and they are short circuited through external resistance. See, this is how we will come to know this is RYB of the rotor winding. That is a rotor winding. These are all brought outside through a slip rings. That is 1, 2, 3 slip rings, and externally these once again these windings are short circuited. You can see here it is externally short circuited. These resistors are used externally so that you have to get the more torque and other things. Okay. That is a basic construction consists of, in the case of the slip ring induction motor, it is consist of a three-phase winding. These terminals are brought outside through a slip rings and externally they are short circuited through a resistance. This is the cross section of a slip ring induction motor. You can see here this is a three-phase rotor winding, and these windings are brought outside through three slip rings. You can see here it is 1, 2 and 3 slip rings, and these are connected through brushes. These are connected externally through the brushes. These are the three brushes. They are using a slip ring, therefore it is called as a three-phase slip ring induction motor. In the summary, the induction motor is a rugged, simple, high efficiency, better speed regulation induction motor consisting of stator and a rotor. The stator consists of a three-phase winding. The rotor has got two different types of construction. One is called as squirrel cage induction motor. The another one is a slip ring induction motor. In the next session, we will see the principle of operation of three-phase induction motor.